In polymer chemistry and materials science, resin is a solid or highly viscous substance, usually containing prepolymers with reactive groups. Such viscous substances can be plant-derived or synthetic. Examples of natural resins. Notable examples of plant resins include amber, balm of Gilead, balsam, Canada balsam, boswellia, copal from trees of Proteum copal and Hymeneocore beryl, dama gum from trees of the family Dipterocarpaceae, dragon's blood from the dragon trees, elemi, frankincense from Boswellia sacra, galbanum from Ferula gummosa, gum guaiacum from the lignum vitae trees of the genus Guaiacum, kauri gum from trees of Agathis australis, labdanum from Mediterranean species of Cistus, mastic from the mastic tree Pistacia lentiscus, myrrh from shrubs of Comifera, sandarac resin from Tetraclinis articulata, the national tree of Malta, Styrax, spinifex resin from Australian spinifex grasses, and turpentine, distilled from pine resin. Amber is fossil resin from coniferous and other tree species. Copal, kauri gum, dama and other resins may also be found as subfossil deposits. Subfossil copal can be distinguished from genuine fossil amber because it becomes tacky when a drop of a solvent such as acetone or chloroform is placed on it. Rosin is a solid resin obtained from pines and some other plants, mostly conifers, produced by heating fresh liquid resin to vaporize the volatile liquid components. Plant resins are generally produced as stem secretions, but in some South American species such as Euphorbia dalachampia and Clusia species they are produced as pollination rewards, and used by some stingless bee species to construct their nests. Propolis, consisting largely of resins collected from plants such as poplars and conifers, is used by honeybees to seal gaps in their hives. Shellac and lacquer are insect-derived resins. Asphaltite and Utah resin are petroleum bitumens, not a product secreted by plants, although it was ultimately derived from plants. History and etymology. Plant resins have a very long history that was documented in ancient Greece by Theophrastus, in ancient Rome by Pliny the Elder, and especially in the resins known as frankincense and myrrh, prized in ancient Egypt. These were highly prized substances, and required as incense in some religious rites. Amber is a hard fossilized resin from ancient trees. The word resin comes from French resin, from Latin resina, resin, which either derives from or is a cognate of the Greek eta tau iota nu eta retine, resin of the pine, of unknown earlier origin, though probably non-Indo-European. The word resin has been applied in the modern world to nearly any component of a liquid that will set into a hard lacquer or enamel-like finish. An example is nail polish, a modern product which contains resins that are organic compounds, but not classical plant resins. Certain casting resins and synthetic resins have also been given the name resin because they solidify in the same way as some plant resins. But synthetic resins are liquid monomers or thermosetting plastics, and do not derive from plants. Plant resins. Plants secrete resins and rosins for their protective benefits. They confound a wide range of herbivores, insects, and pathogens, while the volatile phenolic compounds may attract benefactors such as parasitoids or predators of the herbivores that attack the plant. The resin produced by most plants is a viscous liquid, composed mainly of terpenes, with lesser components of dissolved non-volatile solids, which make resin thick and sticky. The most common terpenes in resin are the bicyclic terpenes alpha-pinene, beta-pinene, delta-3-carene, and sabine. The monocyclic terpenes limonene and terpinolene, and smaller amounts of the tricyclic sesquiterpenes, longupholine, caryophyllene and delta-cadenane. Some resins also contain a high proportion of resin acids. The individual components of resin can be separated by fractional distillation. Rosins, on the other hand, are less volatile and consist inter alia of diterpenes. The composition of resins varies with the species. a notable case Jeffrey pine and gray pine. The volatile components of their wood resins are largely pure N-heptane with little or no terpenes. Some resins, when soft, are known as oleoresins, and when containing benzoic acid or cinnamic acid they are called balsams. Oleoresins are naturally occurring mixtures of an oil and a resin. They can be extracted from various plants. Other resinous products in their natural condition are a mix with gum or mucilaginous substances and known as gum resins. Several natural resins are used as ingredients in perfumes, e.g., balsams of Peru and tolu, elemi, styrax, and certain turpentines. Certain resins are obtained in a fossilized condition, amber being the most notable instance of this class. African copal and the kauri gum of New Zealand are also procured in a semi-fossil condition. Non-resinous exudates, other liquid compounds found inside plants or exuded by plants, such as sap, latex, or mucilage, are sometimes confused with resin, but are not the same. Saps, in particular, serve a nutritive function that resins do not. Derivatives: solidified resin from which the volatile terpene components have been removed by distillation is known as rosin. Typical rosin is a transparent or translucent mass, with a vitreous fracture and a faintly yellow or brown color. Non-odorous or having only a slight turpentine odor and taste. Rosin is insoluble in water, mostly soluble in alcohol, essential oils, ether and hot fatty oils, and softens and melts under the influence of heat. Is not capable of sublimation, and burns with a bright but smoky flame. Rosin consists of a complex mixture of different substances including organic acids named the resin acids. These are closely related to the terpenes, and derive from them through partial oxidation. Resin acids can be dissolved in alkalis to form resin soaps, from which the purified resin acids are regenerated by treatment with acids. Examples of resin acids are abietic acid, C2OH3OO2, glycatic acid contained in cedar, and pyrmaric acid, C2OH3OO2, a constituent of gallipot resin. Abietic acid can also be extracted from rosin by means of hot alcohol. It crystallizes in leaflets, and on oxidation yields trimolytic acid, isophthalic acid and terebic acid. Pyrmaric acid closely resembles abietic acid into which it passes when distilled in a vacuum. It has been supposed to consist of 3 isomers. Uses: plant resins. Natural plant resins were once valued for the production of varnishes, adhesives, and food glazing agents. They are also prized as raw materials for organic synthesis, and provide of constituents of incense and perfume. The hard transparent resins, such as the copals, damas, mastic and sandorat, are principally used for varnishes and adhesives, while the softer odoriferous oleoresins and gum resins containing essential oils are more largely used for therapeutic purposes and incense. The resin of the Aleppo pine is used to flavor retsina, a Greek resinated wine. Synthetic resins. Many materials are produced via the conversion of synthetic resins to solids. Important examples are bisphenol A diglycidyl ether, which is a resin converted to epoxy glue upon the addition of a hardener. Silicone are often prepared from silicone resins via room temperature vulcanization.